is this one. So one of the properties of logarithms
Uh-huh.
says that when you're adding two logarithms together like this, it's the property that says log base b of a plus log base b of, let's call it x and y instead of a and b. X equals some number n. Well, it says that that thing equals, do you remember the properties?
Um,
Log base b of x times y.
X times Y. Okay.
Do you have all those properties written
Yeah,
down somewhere?
they're in my notebook.
Yeah. Have that out because that's super important. Let me see if I feel like I just did this with another student recently. Oh yeah, there we go. I'll put it right onto here so you can see it. Okay. So that property right there is this one. Okay. So what can we do with this? We can rewrite this as log base 2 of multiply x minus 1 times x plus 1. See how I simplified that?
Sorry, what?
Do you see how I simplified that?
Yeah.
Okay. And then once you've got that, now we're going to use the equivalence or the equality rule as it's called right there. See there at the bottom I just circled?
Yeah.
That equality rule allows you to convert, whoops, not that one. So sorry, that's not it. It's the equivalence rule, which isn't on this. The equivalence rule allows you to convert from logarithmic to exponential and vice versa. And it says log base b of x equals y is the same thing as b to the y equals x. Okay.
Yeah.
You remember that? So
Yeah.
this, I'm going to convert this by saying 2 to the third equals x minus 1 times x plus 1. And if you multiply this together, what do you get?
X squared minus 1.
Good. X squared minus 1. Don't even need parentheses around that. X squared minus 1. And that's on the left side. I'm sorry, on the right side. And on the left side, you've got 8. Right? So now to solve this, I can just isolate x squared. So x squared equals 9, which means x equals plus or minus 3. Now you want to be careful because sometimes you get what's called an extraneous solution. And
Yeah.
we have one in this case. So when I try to plug this back in here, if I plug a -3 in here, I can't take the logarithm of a negative number.
So that make it extraneous.
Yeah, so the -3, I'd get rid of the -3 and I just say x equals +3. And you can check by plugging it back in and you'll see that it does work. Because the log base 2 of 2 plus the log base 2 of 4, 2 to what power equals 2? 1. 2 to what power equals 4? 2. And that equals 3. So you can see that that works.
Cool.
Okay.
Yeah.
All right. Let's see what the next question is. The next question is that one. Okay, so the next question. Let's see if it's going to let me paste. Well, it didn't work that time. I was a little too happy about that. I don't know why that didn't work, but let's try it again. Done. Copy and delete. Okay, let's try. There we go. I had to put my pen down. Okay, there's the next question. So for this one, I am going to try to get x by itself. And I'm going to get x by itself by getting rid of everything else. So first I have to get rid of the 2 by doing what?
Adding 2 to each side.
Good. So 795 equals e to the 1 plus 5x. Now I'm trying to solve this for x. So how do I get this out of the exponent?
You have to put it in natural log.
Yeah, I take the natural. What I like to do is just to take the natural log of both sides. Because you remember one of those properties, this is the best of all the properties, the power rule. You see that? I can take the power and I can bring it down front and make it a factor. So I write this as 1 plus 5 to the x, or 1 plus 5x times ln of e equals ln of 795. And what's the ln of e?
1.
It's just 1. So I've got 1 plus 5x equals ln of 795, right? Remember, I'm trying to get x by itself. So what do I get rid of first?
You subtract 1.
Good. So subtract 1. So now I can't subtract that from what's inside there. I got to subtract it on the outside, right?
Yeah.
So just to be clear, I'm going to do it like that. And that means I have 5x on this side. Now I get rid of the, or how do I get x by itself now?
You have to divide each side by 5.
Very good. So this is your answer. And if they want you to write it as a decimal, this was the exact answer. And if they want you to write it as a decimal, just punch it into your calculator. ln of 795, which isn't a pretty number, minus 1. Hit enter, and then divide that by 5 and hit enter, and there's your answer. So it's approximately
Okay.
1.14. Now, I can check that. Watch what I'm doing. I'm going to store that answer for x in my calculator. The store button should be in the lower left-hand corner right above the question mark. And now I'm going to rewrite that equation. E to the 1 plus 5x, and it's going to plug in that value for x, minus 2, and I should get 793. And I do, so I know I did it right.
Okay.
Good?
Yep.
Whoops, wrong one, sorry. Okay, next question. All right, so this is another simplifying question. Oh, didn't mean to do that.
For this one, it says to expand completely and simplify if possible.
Yeah. So this is a different kind of question. This is saying, man, just not getting, I'm not getting too lucky with this. Son of a gun. I don't know why this is working sometimes and not other times. All right, ln of cube root of a over b squared. I'll just write it down. ln of the cube root of a over b squared. Is that right?
Yeah.
Okay, so I'm going to rewrite this first using what I know about cube roots. What's a cube root? What's the power of a cube root?
1/3.
Perfect. And now I'm going to use that one power rule that I just talked about, right? What can I do with this with this exponent?
You can bring it to the front.
Very good. So I bring that to the front. And then I have ln of a over b squared. And then I'm going to use that one rule that I talked about earlier. This time it's the division rule. So the property is this one right here, the quotient rule.
Yeah.
Got it. The quotient rule says that I can split this up. So I'm going to leave that 1/3 out front with parentheses around it. And now I'm going to break up that ln of a minus ln of b squared. Get how I did that?
Yeah.
Now I'm going to take this 2 and use that quotient rule again and bring it down front. So I have 1/3 times ln of a minus, and then this becomes 2 ln of b. Okay.
Yeah.
And then I can expand it even more by distributing the 1/3 in. So this is 1/3. Let's try that again. This is 1/3 ln of a minus 2/3 ln of b. And that's the most expanded that I can do it. So that's where I'll leave it.
Cool.
Okay?
Yeah.
Questions about how I did that, or does that make sense?
That makes sense.
8 to the x equals 1,000. 8 to the x equals 1,000, and they want you just to solve this. Now, that's not going to have a perfect solution. So what you're going to do is just take the log of both sides. And that allows you to bring the x down to the front. So x times the log of 8 equals the log of 1,000. Now, the log of 1,000 is just 3, right?
Oh, because it's 10 times 10 times 10.
Yeah. So
Yep.
you could simplify that right away. In fact, I can just cancel that out and call that just 3. Right? So then x equals 3 over the log of 8. And they probably said rounded to 3 decimal places or something like that.
Yeah.
All right. So just plug that in your calculator. 3 divided by the log of 8. And remember, log is just giving you log base 10. That's all it's doing.
Yeah.
So x is approximately 3.322. And now let's just check it. Let's store that for x. Hit enter. And now let's just type in 8 raised to the x, and it should give us 1,000. So always check your answer when you're done.
Okay.
Okay, see how I did that?
Yeah.
Negative 2/3 ln of 3y. Negative 2/3 ln of 3y, like that. Did I write that right?
Yeah.
And they want us to do what here?
To write each
Go ahead.
as a logarithm and condense.
To rewrite it as a condensed logarithm?
Yeah.
And that was the problem they gave you?
Yeah.
So they don't want you to expand it, they want you to condense it.
Yeah, condense.
Okay. So the only real way I could condense this is by bringing that up to the front, to the top. ln of 3y to the negative 2/3. And now maybe they want you to just kind of write that in a more condensed way. I'm not really sure. So that would be
Oh, they have negative exponents, that's why.
okay. So that would be ln of 1 over 3y to the 2/3. But you could simplify that if you wanted to and write it as, see, they probably don't want you to have a cube root in the bottom either. Did they say that?
No, you can have those.
Okay, so that probably is the right answer then. Do you
Okay.
have the way to check the answers?
Yeah, there's an answer sheet.
So just check, because otherwise, sometimes they'll say, "Oh no, you have to rationalize the denominator," because technically, right now, what you have is this: you have the cube root of 3y squared. That's what you have currently. And they may say, don't have a cube root in the bottom.
I think that's allowed. I'm pretty sure we're allowed to have that.
Okay. Just check your answer, because otherwise it's a little bit of a mess, but I can teach you how to do it. I just don't know if they want you to do it or not.
Yeah. Show me, because I'm not really sure what they want.
What'd you say? You want me to show you?
Yeah.
Okay. So the way you would do that is you need to turn this thing into, it's like you have to get rid of the 1/3 power there. So what you would have to do is you would have to multiply, let's take 1 over 3y to the 2/3 power, and you'd have to multiply that by 3y to the 1/3 power, like that.
Okay.
So that these add together to make 1.
Okay.
So that would give you 3y to the 1/3 power on the top. And on the bottom, you would just have 3y.
Okay.
Do you get what I did there?
Yeah, you just multiplied both sides to get rid of the
Yeah,
exponent.
the top and bottom, right? Both sides of the fraction.
Yeah.
So another way to write this that they may want you to do, again, I don't know if they do, is this is the cube root of 3y on the top all over 3y on the bottom.
Yeah, so on the homework key for us, it says the answer is natural log, and then it's 1 over the cube root of 9y squared.
The cube root,
Cube root of 9y squared.
yeah. So all they're doing, all he's doing there is taking this 2 and putting it inside here.
Oh, okay.
It's still the same problem that you have with it.
Yeah.
I would argue that that's not more simple than this right here. And if they don't want you to have a radical in the denominator, then what he did didn't really help you
Okay.
much, because now you got to get rid of that still in the denominator.
Yeah, I think we're fine with radicals in the denominator since it was
Yeah.
on.
Okay. What else you got? Is that
Oh,
it?
yeah.
All right.
Thank you.
All right, man. Do you have any other questions? You feel good about it?
I think I'm gonna do go on a quiz.
All right, good. Yeah, just check out. You can also check out more of my problems on my website.
Okay.
Um, you can see I've got all kinds of examples of this as well. More examples for it. All right. Good luck.
Thank you.
All right. See you.